Okay, so here we have one more example looking at a differential equation. In this case, we have p as a function of t that we want to solve for, and you'll notice this one will be a little bit more difficult on the right hand side to actually separate the variables from each other. So we're looking to factor this, and what I want you guys to do is just pause this video, try to separate these variables, try to solve the differential equation, and then come back. I'll go through the full solution. So looking at the right hand side, factoring it, okay, hopefully you realize that here on the right hand side we can group it. Okay, now this is not something that we do very often, okay, but I can factor from the first term and I can leave my second term as is. What I end up with is going to be p multiplied by t squared minus 1 plus t squared minus 1. Okay, and that's going to be my right hand side. On the left we still have dp dt. So now I can finish factoring, and I end up on the right hand side with p plus 1 multiplied by t squared minus 1. On the left we have dp dt. Now I bring over my dt to the right hand side, so I will have all the t's on the right, and I can bring my p variable over to the left with dp, and what we end up with here is going to be dp divided by p plus 1 is going to be equal to t squared minus 1 multiplied by dt. Now we are ready very much to integrate. And on the left, it may not look so nice, but think for a moment, how do we integrate this one on the left? We have dp divided by p plus 1. Can't really simplify it, but you can do a substitution, or you can recognize this is very similar to what we saw in partial fractions case 1. It's just going to give us a logarithm. Ln of p plus 1 on the left is equal to 1/3 t to the power of 3 on the right minus t, and now we put in our plus c. Okay, let's actually go through. Let's solve for p here. So we can drop our logarithm and then drop the absolute value. We get absolute value p plus 1 is equal to e to the power of 1/3 t to the 3 minus t plus c, and then we get p plus 1. And actually, let's just take it one step further. We're going to get that p is equal to plus or minus this exponential. And I'm going to bring over this minus 1, or this positive 1 to the right, where it will become a minus 1. So we have a minus 1 there at the end. And that's going to be our general solution. Okay, you'll notice that we never actually were able to solve for the value c here. We don't have an initial condition, so this is our general solution.